Today's topic is matrix. Okay. First of all, we'll discuss the definition. Okay. A matrix is defined as a rectangular array of m cross n number arranged in m rows and n columns. Okay. I'll write it down here. A matrix is defined as a rectangular array of m cross n numbers. M into n. Okay. M into n numbers arranged in m rows. Okay. Rows and m columns. Okay. Suppose I will tell you the example. A1 is the what? Row. Okay. N cross n, right? M for rows, n for columns. Row 1, column 1. Okay. A1 2, row 1, column 2. The element position is row 1, column 2. Okay. A1 3, row 1, column 3. Okay. Like that up to A1 n. Okay. A2 1 means row 2, column 1. Okay. This is this way. This is the column, and if we go horizontal, that is row. Vertical ones are columns. Okay. A2 2, A3 3 till A. Sorry, here it is 2. To n, like that till am1, am2, am3 till amn. Okay. This is the matrix of technical issue. Sorry. Okay. This is the matrix of m by n. Okay. Just take a screenshot of it. Okay. And we will discuss the types of matrix. Okay. Types of matrix. The first one, square matrix. Okay. Here number of rows and number of columns are same, then we will call it as the square matrix. Okay. so number of rows equals to sorry, number of columns. Okay, that is m equals to n. Okay, example 1 0 1 5 1 2. Suppose if we take this matrix, this is square matrix because 3 by 3 matrix it is. Okay, here it is the m, here it is n. So rows are 3 and columns also 3. So this matrix called as square matrix. Okay. Take a screenshot. Okay. And the second one, diagonal matrix. Okay. Diagonal matrix. Okay. If the elements of elements other than the diagonal elements are 0, then it's called as diagonal elements. Okay. If the elements other than diagonal elements, okay, other than the diagonal elements we are zeros. Okay, other than the diagonal elements, if the other diagonal if the elements other than the diagonal elements are 0, then it's called as diagonal matrix. Okay, by looking at the example we will get to know what is the diagonal matrix. Okay, 0 0 6 0 0 0 9. Okay, see here, this is diagonal. Okay. Other than the diagonal matrix are 0. Here, so see 169 only remain. Have the values other than that. Every position it is 0. Okay. Just take a screenshot of it. You will find the values on the diagonal only. Okay. Other than the diagonal, we will find the 0 values. Okay. Third one, scalar matrix. It is just like diagonal matrix, but small change. Okay, if all the diagonal elements are same scalar. Okay, I mean if the diagonal matrix are repetitive, I mean if okay, I will tell you in the example, you will get to know that. Okay, I will write the definition. If all the diagonal elements be the same scalar. Sorry, be the same scalar. Be the same scalar. Okay. Example is 2 0 0 0 2 0 0 0 2. See, these all are square matrix. Okay. Here also it is 3 by 3. Okay. See here in the diagonal, you will find the numbers are same, right? Here, okay, same numbers are repetitive. Okay, same scalar. Remember this. Alternatively, if we take 999 in the diagonal, then the same number has to come. Okay, then we will call it a scalar matrix. Okay, the fourth one is null matrix, null or zero matrix. Everyone knows this matrix. Okay. Every element of the matrix are 0. Okay. If all the elements of matrix are 0. Are 0. Okay. Example 0 0 0 0 0 0 0 0. Okay. These are square matrix. Okay. Take a screenshot and make notes of it. Okay. Fifth one, identity or unit matrix. Okay. Identity or unit matrices. Unit matrix. Okay. If all the diagonal elements are 1. Okay. Just like a scalar, we don't use 1 there. Okay, because if we use the 1, then it becomes the identity or unit matrix. Okay. Just like the scalar matrix, but 1 is used here. Okay. If 1 is in the diagonal matrix and remaining elements are 0, then it is called as unit matrix. Okay. all the diagonal elements are 1. Okay. One and elements other than diagonal elements are 0. Okay. Example 1 0 0 0 1 0 0 0 1. Okay. It is 3 by 3 matrix. 1 0 0 1 is 2 by 2 matrix. Okay. It happens only on the square matrix only. Okay. Just remember all those things. Take a screenshot. Okay. And the sixth one, upper triangular matrix. Upper triangular matrix. Okay. A square matrix having all elements below the diagonal elements equal to 0. Okay. Having all the elements below the diagonal elements equal to 0. Okay. Example 1 2 3 0 5 6 0 0. Okay. Here this is the upper triangle. Okay. A square matrix having all elements below the diagonal. Okay. This is the diagonal elements 1 5 6 1 5 7 other diagonal elements, and below the diagonal elements are 0. Okay. Equal to 0 or elements are 0. Alright, as equal to 0. But anyway, that's the definition only. Okay. Take a screenshot of it. Think 7th, right? Yeah. Lower triangular matrix. A square matrix having all elements above the diagonal are. Okay. Above the diagonal are equal to 0. Okay. The previous one below the diagonal are 0. Here the triangle will form on the above. See here. For the sake of remembering the matrix, I'll tell you. If you see the triangle formation on the above, okay. See these thing, okay. This is the 1, 2, 5, 6, and 7. See, observe this forms the triangle here, right? And a square matrix having all elements above the diagonal equal to 0. Okay. Let us say 1, 0, 0, 2, 3, 0, 7, 5. See here the triangle formed the below. Okay, just remember like that. Okay, it reflects how it reflects a triangle. Okay, above the diagonal elements are 0. Okay, the lower triangle means triangle forms in the lower side. Okay, that's all. Okay, and eighth one. Idempotent matrix. Okay, idempotent matrix. Here you have to remember a square equals to a. If this happens, then the matrix is called idempotent. Okay. Suppose I will give you the example. Suppose if we take a equals to 2 minus 2, 4. So minus 4. Okay. Minus 1, 3, 4, 1, minus 2, minus 3. This is the A matrix. Okay. Just A square means multiply the matrix 2 times. 2 minus 2. I think it's minus 4. Okay. Minus 1, 3, 4. Yeah, here it is minus 4. 1 minus 1 minus 2 minus 4 minus 1 3 4 1 minus 2 minus 3. So it all same. If the answer is the same as the A, okay, 2 minus 2 minus 4, just find the multiplication, okay, minus 1 3 4 1 minus 2 minus 3. If the multiplication of A square is equals to same as the A, then we will call it as idempotent matrix. Okay, not finding the answer here, just for the sake I have given. I don't know whether it is right or not, but I try it. Yeah, this is the idempotent matrix. I think try on 2 2s are okay. I'll do it now. 2s are 4. Minus 2 minus 1 means plus 2 minus 4. It is cancelled. It is coming as 2. Okay. Minus 4 minus 6 plus 8. So here it is. Here it is minus 2. Right on. I think somehow. Okay, do the multiplication and find it as. If A square equals to the A, then it is called as idempotent matrix. Okay. I'll erase the work. Okay, now think 9th, right? 9th one. Symmetric matrix. Symmetric matrix. Here A transpose equals to A. If A transpose equals to A, then the matrix is called A. Sorry, symmetric matrix. Okay, and it is a square matrix also. Square matrix only happens, right? Square matrix. Transpose means rows becomes the columns, columns becomes the row. I'll give you the example. Okay. Anyway, 1, 2, 3, 1, 2, 3. How to row column. It's just a one. I think. Suppose if we take this matrix This is the row. Okay. This row we will write it as the column. Row to column. Okay. 1, 2, 3. This we will write it as another column. 2, 3, 4. Okay. Somehow it happened. Okay. 3, 4, 1. Okay. Like that, if the transpose is same as the original matrix, then we will call it a square matrix. Okay. Not only this one, if we write this column as row 1, 2, 3, right? This next column as 2, 3, 4, and first column 3, 4, 1. Same, right? So just like that, any one method. If this is same, then we will call it a symmetric matrix transpose. And 10th one, skew matrix, skew symmetric matrix. Skew symmetric is also same as, but we will find the negative sign here. A transpose equals to minus of A. Okay. It is also a square matrix. A square matrix. Okay. Example. 0, 7, -2, -7, 0, 5, 2, -5, 0. Okay. This is the A matrix. If we will write A transpose. Okay, same as the previous one. Rows becomes columns. 7, 0, 7, -2, -7, 0, 5, 2, -5, 0. Here you will find the values are just reverse. I mean, if the negative sign is coming here. Okay. Observe the things. Okay. We also to. Okay. So A transpose is equals to minus of A. I mean negative of A. That is a skew symmetric matrix. Okay. And one more thing I have to observe here, the main diagonal elements. Okay. Here are 0. I forgot to mention that. Okay. I'll write the definition. It is a square matrix and main diagonal elements are 0. Main space. Main diagonal elements are 0 and satisfies the to A transpose equals to minus A. Then it is called the skew matrix. Okay. Just remember, just take a screenshot of it. Okay. And make a note. Okay. A matrix can be expressed uniquely as a sum of symmetric matrix and skew symmetric matrix. Okay. A matrix can be expressed uniquely as a sum of symmetric and skew symmetric matrix. Symmetric and skew symmetric matrix. Okay. You have to remember this one. May come directly as a bit. Okay. And orthogonal matrix also. Orthogonal matrix. Orthogonal matrix. A n by n matrix. I mean, it is a square matrix. Okay. Matrix A is said to be orthogonal only if it satisfies the if A transpose A into A transpose equals to IN. Okay. IN means what? Any guesses? Identity matrix. Okay. Don't forget the basics. Okay. here determinant is plus or minus 1 into A transpose equals to IN. I'll write that is identity matrix. Okay, why I have write unknownly, it is the square matrix here. Okay, sorry, just remember like that. Any, just take a screenshot of it. We have to discuss the properties of matrix. After that only we will get to know some remaining matrix. Okay, like singular. Okay, we can tell the singular matrix. Okay, we'll write it down. I think oh, singular matrix. A square matrix is singular only if, okay, write the definition. A square matrix, yeah, okay, is singular if depth of A equals to 0. Okay, this is the condition. If the determinant is 0, then it is a singular matrix. If not, that is non-singular. Okay. Non-singular matrix. If that is not equals to, that means determinant, okay, that is not equals to 0, then it is non-singular. Inverse matrix is there, and few more there. We will discuss after the completion of properties of matrix and properties of determinant, like that. Okay, it's the end of the session. Okay, we'll meet later. Just remember all the things. I will just recap everything. Okay, matrix is defined as a rectangular array of m cross n numbers arranged in m rows and n columns. Okay, and types of matrices. Square matrix is number of rows are equals to number of columns, called as square matrix. Okay, square matrix. And diagonal matrix, if the elements other than diagonal elements are 0. Okay, only diagonal elements have the values, other than the diagonal elements are 0, then it is called as diagonal matrix. Okay, scalar matrix, if all the diagonal elements be the same, scalar. Okay, if it is 1, we will call it as identity or unit matrix. Don't forget this one. Okay, if other than 1, if all the diagonal elements be the same scalar, like diagonal elements are 2 and 3, like that. If we here we consider the 2, so okay, a1 element is 2, a2 element is 2, a3 element is 3. It is the diagonal elements, the same scalar. Okay, null or 0 matrix. Okay, every element of the matrix is 0, identity or unit matrix. Okay, if all the diagonal elements are 1 and other elements other than the diagonal elements are 0. Okay, here we will find diagonal elements are 1 and other than diagonal elements are 0. Upper triangular matrix, a square matrix having all elements below the diagonal elements equals to 0. See here, we are forming a triangle. Okay, upper triangle, and below the diagonal elements are 0. Same as the lower triangle, also the same. A square matrix having all elements above the diagonal equals to 0. Okay, idempotent matrix. A square equals to A. Okay, this is the condition. And symmetric matrix A transpose equals to A. This is I have told you. It's a square matrix. Skew symmetric is A transpose equals to minus A. Okay, it is a square matrix and main diagonal elements are 0, and it has to satisfy the A transpose and minus A. Here we have to remember the main diagonal elements are 0. Okay, just remember the thing. Okay, I am highlighting here also. Okay, the main diagonal elements are 0. I will upload the page also if possible. I'm not sure, but I'll try to make a notes PDF. Okay, matrix can be expressed uniquely as sum of symmetric matrix and square matrix. Okay, a matrix can be written as the sum of, if we sum the symmetric matrix and square matrix, we'll find a matrix. Okay, that's the orthogonal matrix. Everything is covered, right? Yeah. A uncrossed a square matrix A is said to be orthogonal if A into A transpose, multiplication of A with A transpose is unit matrix, identity matrix. That is also the square matrix. Okay, and singular matrix is determinant of matrix is equals to 0, then it is called a singular matrix. I will tell you that how to find the determinant and all in the next class. Okay, non-singular matrix means if the determinant of determinant of a matrix is 0, then we will call it as not 0, not equals to 0, then we will call it as non-singular matrix. If the determinant of a matrix is 0, then we will call singular, if not non-singular. Okay, that's all. Today's session we are going to end. Okay, thank you.